Welcome. Today we're going to be learning about constructions. To the Greeks, where the current formalized study of geometry started, all knowledge was broken down into its most simple parts, which for constructions was the use of basic tools, the compass, and the straight edge. A straight edge is just a ruler without numbers. We'll be using rulers because I don't have straight edges, but we'll be ignoring the numbers. To a mathematician, there is no exact measurement or perfectly reliable tools. Only measurements and tools with less and less error. Right? So rulers and protractors are only as good as your eyes are at seeing those measurements, being able to figure out exactly where an angle or ends or a segment ends. And then protractors and rulers, they get worn down, so maybe their measurements aren't exact. The key to constructions is that they can be proved to exhibit the relationships shown, not just drawn to show the relationships. Right? So the constructions themselves actually prove certain things true about different geometric figures. That's why constructions and proof are so important in geometry. Constructions are a way to visualize the formal structure of proof in classical geometry. And later on in the year we'll be doing some proofs. Geometric constructions, also called Euclidean constructions, after the ancient Greek mathematician Euclid, are geometrically correct figures that are drawn using only a compass and a straight edge. Okay, so that means if we're drawing a square, it has to have 4 90-degree angles. It has to have sides that are all the same length. And we can use constructions so that actually works out to be true. In creating a geometric construction, measurements of angles and lines are not taken, and rulers are not used except as straight edges. This method can be used in drafting, technical designs in engineering, and as a way of learning the fundamentals of geometric theory. So why learn constructions? First of all, visualizing geometry. Constructions help students to visualize geometric figures and relationships, interpret geometric designs, interpret geometric diagrams. These activities are essential to a clear and complete understanding of geometry. Constructing accurate geometric diagrams is very helpful in increasing the student's ability to draw, visualize, and interpret mathematical diagrams. Creativity in mathematics. Constructions can provide opportunities for students to explore their own creative abilities. Understanding geometric relationships. Exploratory geometric constructions help to develop understanding of formal geometric concepts and proofs. Euclid's original approach to geometry was based on constructions. Traditionally, geometry courses have included constructions, but more importantly, proofs of constructions are essential to understanding. They both apply and verify the theorems of geometry. So our constructions themselves actually prove certain things to be true. Continuing on, why learn constructions? Geometric constructions are all around us. Geometric construction is used in building highways and architectural structures. So here we have a highway, and here we have an architectural structure, a building. Architects and engineers must know the elements of geometric constructions in order to create precise technical drawings for designs of machinery or buildings. Although automated computer-aided designs, CAD systems, have replaced manual drawing in most engineering settings, geometric constructions are still widely taught as background information for understanding the principles of design. So if you're interested in designing something, geometric constructions are important. And so the straight edge is generally a clear plastic tool devoid of markings. It most often appears in the shape of a triangle. A portion of a straight edge is visible in the lower left corner of the picture on the left below. So over here, I think you can see my pointer pointing to it. In the very lower corner there, and actually I can draw an arrow to it. This right here, come on arrow, right, that is a straight edge. Here we have a couple compasses. These are compasses like I have. Notice this bar right here. That helps to keep the compass locked in place so it doesn't fold over and mess up on you. We'll also be using good old rulers. We're just not paying attention to any of the markings on the ruler. So if you don't have a straight edge, a ruler may be used. Just remember to completely ignore the markings on the ruler. Compasses come in a variety of styles. Become familiar with the compass you'll be using before beginning your constructions. This one right here is the best of the compasses because it'll stay locked in place. Right? Some of the other ones don't lock as well. These two that are shown, sometimes they're not too bad. This one here and this one here. Just it all depends on the compass. But if you have a locking bar, you know it'll stay. Suggestions for working with a compass. Place several pieces of paper under your worksheet to allow the compass point to remain stable. Hold the compass lightly and allow the wrist to remain flexible. Right? You don't want to push too hard, right? Because it might bend the compass and then it messes up what you're constructing. If you cannot manage to move your wrist when drawing circles, try rotating the paper under the compass. So keep your wrist steady and just rotate the paper. Right? Sometimes I do a little bit of both. I'm going to be doing constructions up on the whiteboard using the smartboard tools. You'll be able to see the steps and my hand won't be in the way. So it'll work out a little bit better than if I were to try to show you with actual tools. So here are some rules for constructions. In construction, aside from the tools, there are specific rules to be followed. These rules are the following. The point rule. A point may be given. It may be the intersection of figures that have been already constructed, or you may choose an arbitrary point on a line, circle, or on a plane. You can also choose a point not on a line or circle, as in pick any point not on segment AB. So sometimes we're given points, but if you need a point, you can place a point anywhere you like. Straight edge rule. A straight edge can draw the line AB through 2 points. A and B. So if you have 2 points, you can use a straight edge and connect those. The compass rule. A compass can draw a circle with center at point A containing a second point B. So point B would be on the circle and point A would be the center of the circle. You can also use a compass for arcs. So it can draw a circle and an arc, which we learned in the geometric definitions is just part of a circle. Very, very important, never draw freehand when doing a construction. Right? Otherwise, what you're trying to construct will not hold the properties anymore. Right? So freehand will not work when doing a construction. You have to use the tools and use those correctly and use the correct steps. And that's what we're going to be going over. All right, so Euclidean constructions. The first one we're going to do is copy a segment. Then we're going to construct a perpendicular bisector of a segment. We're going to construct a perpendicular line from a given point to a line not containing that point. We can construct a line perpendicular to a given line at a point on a line. So when we're constructing perpendicular lines, it could be a point not on our line. It could be a point on the line. We could be just dividing our line in half for the perpendicular line, and then we have perpendicular bisectors. We can bisect an arbitrary angle, and as a reminder from our introductory activity, bisect means to divide in half. We can copy a given angle to a given ray with a given vertex. Given a line and a point not on a line, we can construct a line parallel to the given line. We can construct isosceles triangles, equilateral triangles, squares, and regular hexagons. So we'll be constructing all of those. Here we have a painting. It's called The Measurers. It is a Flemish image of mathematics in the 16th century. For the things of this world cannot be made known without a knowledge of mathematics. Roger Bacon. Everything that goes around you is governed by mathematics. Everything that we're able to create, everything that we're able to understand is only possible when you understand the mathematics behind things. So let's point out to some geometric tools that are in this picture. Here I see a compass. I see a whole lot of straight edges. I think this one is also a compass. It's kind of small for me to see for sure. But that one looks like maybe that's a compass. I see a bunch of straight edges. I have a straight edge here, one here, and one here. Those are all straight edges. Let's see if we see any others. Oh, look at that. Here's another one. So here's a compass right here in his hand. Right? So those are some of the compasses and straight edges I see in this picture. And these would be Flemish mathematicians at work. Right? So this was just a little background about constructions. I've given you a almost complete set of notes, and it has all the steps. There are a few constructions that you'll do as part of your notes. There's spaces for it. And you can do it if you'd like while watching the podcast, or you can do it later in class and have me help you. Either is fine. Right? So you can just watch the podcast, and take a look at the steps, make sure you understand them. Or you can watch the podcast, pause the tape, and then do the constructions with me, or after I've done them, or while I'm doing them. Probably you want to do the constructions after I've done it, unless you want to keep pausing step by step. Or you can, just watch the podcast and then do the constructions after, right? So it's your choice whether you want to do the constructions while you're watching the podcast or after the podcast. It doesn't make any difference to me. It's just whatever's easier for you. All right, and so this is the end of this podcast. In the next podcast, we're going to be actually doing some constructions. All right, bye for now.